Hello all, welcome to Code Hub. Today let us solve the LeetCode study chapter. The question is jump keep 6. You are given a 0 index integer array nums and an integer k. You are initially standing at index 0. In one move, you can jump at most k steps. In one move, we can jump at most k steps without going outside the boundaries, obviously. And the index I to any index in the range of I plus 1 till minimum of n minus 1 till I plus k. So you want to reach the last index of the array, which is n minus 1. So your score is the sum of all nums of j for each index j you visited in the array. So we will try to go from brute force approach to the optimal. So for each index, if we want to consider, if we visit this index, then we can go either one jump or two jump. For getting the optimum answer, here they have done one jump, then it is 1 minus 1 0. Then from here they have taken two jumps, then the total score will be 4, and from here they have taken two jumps, the total score will be 7. So 4 plus 3 7, so 7 is the optimal answer that you can get maximize. So we have to maximize it. So we have, for each index, for considering in each index, I can take k steps. I can take from plus 1 plus 2. For this index I can take plus 1 plus 2. So I have many possibilities. So I have choices. Obviously if we have any choices, then we can go for a recursive solution. So I will write the recursive function passing the parameters nums k and 0. 0 is the index I. So now I will define the recursive function vector of int ampersand nums int k and int I. So if I has reached my end of the array nums dot size, then I can say return 0, or else I will declare a value which is minimum int min. Since I have to get the maximum score, I will say it as max score, and I can, for each and every index I can go at most k steps. So I will have a variable steps that starts from 1 till steps less than or equal to k steps plus plus. My int next step equal to I plus steps. If my next step is greater than, or if my next step is greater than or equal to my num dot size, then I can just break this loop and come. This would be one more case where I can handle. Or else I can find the current score, considering I'm taking this steps count. So I can include this index. The included index is nums of steps plus solve of nums k and next step, and I will update my max score as well. So max score is nothing but max of max score comma cur score. So and finally I will return max score. So this will be my recursive approach. I will be taking all the possible cases. Max of max score cur score. Sorry. Now we will try to run the code here. Sorry, it is cur score. Oh, this is nums of steps. It is nums of next step. Next step. Now we will try to run the code. runtime error. Let us see where it gets overflowed. Nums of next step. If my next step is get like I plus steps count, next time is greater than my nums dot size, then I am breaking this loop and I will calculating the current score. Nums of my next step plus solve of nums k and next step, and I'm going to that index and I will be taking the all the k steps. If I'm going to reach nums dot size -1, then I will just return 0. From further that I don't want to take steps. Yeah, I want to reach the end of the array. So here I have to for every result I'm going to include my first element, because as you can see that when I call this recursive function, it goes to this call and then I will declare a max score variable. Then I will not include this first element and rather I will include the next element. The steps count as 1, so 0 plus 1, so I plus 1, which is 0 plus 1 1, and I'm going to add the nums of 1 only. I will not be adding nums of 0 itself. So what I can say is nums of 0 can be added here. Always I'm going to add nums of 0, the score which is at the first index, and then I'm going to call this recursive function. So hope this makes clear. Here we are seeing every possible cases, but this will not get accepted as the constraints. Constraints is nums dot length is 10 power 5 and k is 10 power 5. It grows exponentially. The time complexity will be exponential in nature. So we can try to memorize it. For memorization, we want to see what are the changing parameters. The changing parameters is only the int I. I is the I varies till 0 to n. So I will declare a 1D array vector int dp of size nums dot size, and I will initialize with -1. I will pass the dp vector in Amazon dp, and I will pass dp here as well, and here dp of I equals to, and I should check if my dp of I is not equal to -1, then I will just return dp of I itself. Now I will run the code. It got accepted. Let us sum it now. We have memorized it. Here what will be the time complexity? Here this recursive call will go for order of n. So the time complexity will be order of n into, and here we are running a for loop. For every index we are running a for loop, so it will run for k steps. So order of n into k. As you can see, the n grows till 10 power 5 and k is also 10 power 5. So it will be 10 power 10. So 10 power 10 is a n square solution. So this will give a TLE obviously. The space complexity is order of n. We are using an extra space of order of n, and an auxiliary stack space too. We are going to use auxiliary stack space. So the for recursive solution, so we can try to submit the code. So we get time limit exceeded for this. So how can we optimize this further? So let us analyze what we are doing in reverse manner. Let us take this example 1, -1, -2, then 4, then -7, then 3. So obviously from back we will be taking this 3, then the 3 steps, then 3 steps we have taken, and in -7 what is the best steps we can take? -7 plus 3, which is -4. Then from -4, from this 4, what are the three step? What are the next step I can take? Either this minus 7 or this 3. So I will take 4 minus 4 be a 0, or I will be taking 4 plus 3 7. So I will be taking 4 plus 3 7. Next I will be taking a minus 2. Either I can take this 7 or I can take this minus 4. So which is best? I will be taking minus 2 plus minus 4, which is minus 6. Minus 6 is best, or 7 minus 2 5. 5 is best. So I will be taking 5. Next minus 1, I will be taking either 5 minus 1, which is 4, or 7 minus 1, which is 6. I will be taking 7 minus 1, which is 6. So I will be taking 7 minus 1, which is 6. I can move only k steps, which is 2 steps. So what I'm doing, can you observe that? Hope it makes sense. Then in 1 I will be taking either this 6 or this 5. So 1 plus 6, which is 7, or 1 plus 5, which is 6. So I will be taking the maximum, which is 1 plus 6, which is 7. So I'm filling this DP array in the reverse fashion. So for each iteration I will be going, for each index I will be going to every k steps forward, and I will be checking which is best. So obviously for each and every step I am getting the maximum element of that. I will do a dry run once again so that it will be more clear for you. I will be coming from reverse. I am taking this current, I will be taking this current element 3. So I have filled it. So in minus 7, from minus 7, what is the maximum element on its right? It is obviously 3. So I will be taking minus 7 plus 3, which is minus 4. Then from this current index, what is the greatest element in these two elements? It is obviously 3. 4 plus 3 7. I should not see all the elements that are in right. We are having only k steps, so we have to take care of those k distance also. So 4 plus 3 7. In this minus 2, what will be the best option that I am going to choose? I cannot choose, I cannot have a choice of choosing every the elements in the right. I will be having a choice for only 7 and minus 4. So in minus 2, what will be the best possible element that I can choose is, obviously it is 7. 7 minus 2, which is 5. So I will say it as 5. In this index in this element minus 1, what is in this with this code, or what is the best element that I will be going to choose? I will be choosing 7. So 7 minus 1, which is 6. So I am just want a greater element always. I just want a greater element. If I have some way to have a greater element, 7 5, such a way, or 3 minus 4, such a way, what you can understand in this, I am having a monotonically decreasing elements of k elements monotonically decreasing k elements. If for each index, if I can maintain a monotonically decreasing k elements, then I can say to calculate the current index I, consider the dp of I is the current index. To calculate the current index dp of I, I will say the some data structure, consider for monotonically decreasing k elements, I am having some data structure ds, data structure dot front of that the element which is at the front plus my nums of I. So this makes sense, right? It makes sense. dp of I is nothing but data structure, that data structure of front element, which is going to give me the greatest element of k distance plus that nums of I. And then I will obviously insert this dp of I to that monotonically decreasing k elements. So to maintain monotonically decreasing k elements, we will be using DQ. which can be inserted insert front and back. So by this I can maintain the to maintain the order, so that I can reduce this scale loop. Instead of going for a n square solution, we can reduce the scale loop and we can do it in linear method. So for this particular index 1, I want a greater element of 6 and 5. If I have a data structure, if I have a DQ where I have maintaining the 6 and 5, I can take 1 plus 6, which is 7. 7 will be the answer. And I will consider in the data structure DQ, I have 6 and 5. Now I have calculated the dB of IS 1 plus 6, which is 7. So now I have to insert 7 here. How we can insert? I am going to insert 7 if insert 7 if this elements are smaller, then I will be inserting the 7 at the back. So I will be popping this 5 and then I will be popping the 6 and then I will be inserting the 7 to my DQ, right? This is what I'm going to do. Now we will write the code so that it will be more clear. Now we will try to code this approach. First of all, we will eliminate this code. We will have a dp of size n itself. And n equal to nums dot size, and I don't want to initialize it to -1 initially. My last element dp of n minus 1 is nothing but nums of n minus 1. dp of n minus 1 is nothing but nums of n minus 1. Then from last before index for n I equal to n minus 2, I greater than or equal to 0, I minus minus. I will be having a dq, which is my data structure, dq of int. I will name it as dq itself. So this is going to maintain monotonically decreasing elements. This is going to maintain my monotonically decreasing elements. So from the last before index, I'm going to traverse it and I'm going to calculate dp of I is nothing but dq dot friend plus my nums of I. Correct? Yeah, it makes sense. So then I will be pushing this dp of I into my dq if my dq is not empty. If my dq is not empty, and if my dq dot back is less than my dp of I, then I can obviously pop the elements. I can obviously pop those elements. Yeah, I don't want those elements. They are smaller than the elements which are in the back. So I will just pop those elements. dp dot pop back, dq dot pop back. After popping back, I have to insert this dp of I, insert this current element into my back. So dq dot push back of dp of I. Better. And finally, what we are going to return? We are going to return dp of 0. As you can see, in my dp of 0, the value is stored 7. So this is what we are going to do. But is that all the cases are handled? No. For each and every index, we are going to calculate the next k. We are going to maintain the next k elements. But how we can say that this current index, if my current value is the current value is exceeding that k distance. If this element is calculated, and if this element if the q has this element in the front, then this 6 can't be calculated with -4 because it is k distance more than that. So we have to keep some index to that data structure, so that we can maintain them. We can eliminate those elements. So how we can do this? We can instead of inserting elements into our DQ, we will insert the index into our DQ. So we will insert the index DQ dot push back of n minus 1. So instead of DQ dot friend, it will be nums of DQ dot friend, and this is index, right? So the nums of DQ dot back and DQ dot pop back and DQ dot push back of I. And we have to check if my DQ dot friend minus the current index I is greater than k, then I will be deleting that element. I don't want that, so I will deleting that DQ dot friend element, friend index. So hope that makes clear. We are eliminating this k distance elements. That's it. We are nothing doing more complicated. We'll use the example test cases and run the code. We get wrong answer. Let us see where we are making the mistake. Sorry, here if my DQ dot friend minus I is greater than k, I am going to say that I am eliminating that element. So DQ dot pop friend. So I should do that DQ dot pop friend. So I have eliminated that index element. I have eliminated the score at that particular index. So it should be DQ dot pop friend. And then what I'm doing, DP of I is nothing but nums of DQ dot friend plus the nums of I, and then while the DQ is not empty. Hope this is wrong to check. If there is at least one element DQ dot size, then nums dot DQ dot back is less than my DP of I, then I will be popping back that element, and then I will be pushing back the index. Let us check what is happening here. Sorry, before we have said that DP of friend will giving me the value, but this is not DP nums of DQ dot friend. It is DP of DQ dot friend, right? Now I think it will give the correct answer. We have made some silly mistake. It is DP of DQ dot friend, then nums of I. So the same error, it is not nums, it is DP of DQ dot back. Now we will try to run the code. Sorry, it is DP of DQ dot back. Yeah, it got accepted. You will submit the code. It got accepted. So here the time complexity will be order of n, and this while is not going to cost me order of k. So it is just a linear solution. It is order of n. So hope you like this video. So let us see in tomorrow's video, tomorrow's LeetCode daily challenge. Until then, bye.